Next, we're going to take a look at a word problem involving a quadratic relationship. So in this situation, it says that a basketball was thrown upward. So we're going to assume that the player tosses it up into the air. Basketball's flight path is given by the relation y equals negative 0.2 times d minus 2.5 all squared plus 4.25, where h is the basketball's height above the ground and d is the basketball's horizontal distance from where it was thrown, both in meters. We've got three questions here, A, B, and C. So part A says, what was the basketball's initial height, the starting height, above the ground, i.e. just as it was thrown? So if we want to be able to figure that piece out, what we need to do is we need to first figure out and realize that the equation that we're given here in the word problem itself is actually a quadratic equation because it's got the highest exponent here is 2. And not only is it a quadratic equation, but it is a quadratic equation in vertex form. And we know that it's in vertex form because if we take a look at how this equation is structured, it's very similar to, in fact, it's exactly similar to y is equal to a times x minus h squared plus k. So because we know that right off the bat, it's important for us to be able to identify from this equation what are our a, h, and k values. So I'm going to quickly identify my a value, my h value, and finally my k value. So I know from this equation here that my a value is actually negative 0.2. So a value is negative 0.2. My h value is given to us right over here. Now it says negative 2.5, and we already know, and we've talked about this earlier, that when in the equation it's a negative, that actually means that the h value is positive, and the reverse is also true. If this was actually d plus 2.5, then the h value would be negative. However, here we've got negative 2.5, so our h value is positive 2.5. Finally, the last thing that we'll record is that we have a k value that is equal to 4.25. Now, those three pieces of information are going to be really important as we go along and we figure out the answers to part A, B, and C. So part A, I'm going to just move this up a little bit here, says, what was the basketball's initial height above the ground just as it was thrown? So the initial height is the y-intercept. Okay, we are trying to figure out where does it start from. So how high is it above the ground when it begins? And for us to be able to figure that out, we actually have to realize that the initial height or the starting height always happens when the horizontal distance is 0. So in this case, we know that d is 0 because the player has not thrown the ball. The ball has not traveled any horizontal distance whatsoever. So given the formula, y is equal to negative 0.2 times d minus 2.5 all squared. Let me clean that up a little bit just because we want to make it easy to read. So all squared plus 4.25. So that's the original equation that we were given. So in order to figure out what the height is at the initial point, we need to substitute in d is equal to 0. So instead of writing d minus 2.5, we're actually going to substitute in 0 for the value of 2.5. So 0 minus 2.5 all squared plus 4.25. Now this just becomes a matter of following our rules of Bedmas. So when we follow our rules of Bedmas, again, we've got brackets, exponents, division, multiplication, addition, or subtraction. So we're going to deal with the bracket piece first. So we've got y is equal to negative 0.2 times, in this case, 2.5 squared plus 4.25. So our 0 minus 2.5 just leaves us with 2.5. The next thing that we need to take care of is the exponent. Okay, so in this case, we got y is equal to negative 0.2, and then negative 2.5 squared, okay, is going to equal positive 6.25. Okay, and that's me plus 4.25. So next, we need to deal with any division or multiplication. We have no division, but we do have multiplication. So we're going to go, oh, scroll down. We're going to do y is equal to 0.2 or negative 0.2 times 6.25. That equals negative 1.25 plus 4.25. Okay? And then finally, the last thing we need to do is add those two numbers together. So negative 1.25 plus 4.25 is going to equal 3. So that what this means is that the initial height of the ball when it's first thrown is actually 3 meters off the ground. So the next thing that we want to take a look at, we want to examine the answer for part B. Okay? So if we scroll back up and we look at the question here, it says, what was the basketball's greatest height above the ground? Greatest height is a measure of maximum height. Okay, so what this means is what is the max height of the ball as it is thrown up into the air. Okay, now the maximum height is always going to occur at the vertex. We know from this equation, because our a value is negative 0.2, we know that this equation, or that the parabola for this equation, is going to be a downward opening parabola. So we know that somewhere at the vertex is going to be our highest point. And we also know that in any parabola with the vertex form, we know that the vertex is always going to be found at the HK value. Okay, so we know that the vertex here is 2.5, 4.25. Okay, and the maximum height for part B here is going to actually be found when we look at the K value. So our K value is 4.25. So our maximum height, whoop, let's go back and change that. So our maximum height is 4.25 meters. Okay. We can also go back and identify the fact that we've got, for part C here, it says what was the ball's horizontal distance at that point. So when we say the horizontal distance at that point, it means the horizontal distance at the maximum height. So as we go back, we realize that not only is our vertex 2.5 and 4.25, but we can also figure out, therefore, what our horizontal distance is. When we get our maximum height, it happens when the horizontal distance is going to be at 2.5. So 2.5 is actually our horizontal distance because that's how far the ball has traveled in a horizontal manner as the player has tossed the ball. Okay, so 2.5 meters is the horizontal distance. I'll just say distance at the maximum height. Okay, so those being able to identify from the equation the AHK values and determine where the vertex is of any particular thing will go a long way to helping you figure out certain pieces of information as they pertain to word problems that you're going to get as part of this assignment.